Okay, we're going to carry on with 12.7, normal and tangential components. This is a bit of the derivation of the theory and the concepts, the understanding. Again, we have a particle that's going in a curved motion. Instead of 12.5 rectangular components, which are fixed, rectangular components are fixed, we place our axes on the particle as it moves along. So the one thing you need to pick up is that in 12.5, our coordinate system is fixed, which means it is non-accelerating, okay? It doesn't change, non-accelerating, but now we have our normal and tangential axes components, and now as the particle moves, these axes change. They change direction, okay? Whereas before, with X, Y, and Z, the rectangular components, as the particle moves in a curve, the unit vectors I, J, and K, they do not change direction as this particle is moving. Zero change in direction with respect to the axes, right? Okay, but now the unit vectors UN and UT, UN is the unit vector in the N direction, and UT is the unit vector in the T direction. As this particle moves along the curve, these do change. Here, they didn't change, the unit vectors, the ones that gave the magnitude a direction. But here, the unit vectors do change. Okay, so that's just a bit of a background. So this particle is moving like that along a path S, and at that point, let's look at what the velocity is. The velocity is going to be S dot. S dot, which is the change in position, the change in position with respect to time, S dot, in the which direction? Of course, it's in the tangential direction, okay? So there's the magnitude, and there is the direction. Remember that the unit vector, a unit vector just gives the magnitude a direction, okay? And that ends up being V ut. So V is just the speed of the particle at that point. It's just the speed, right? That's the speed, and that's the direction. We know that velocity is always tangent to the curve. Very good. Okay? Now, let's derive our acceleration. How do we get our acceleration? Well, we know that it's d dt of our velocity, which is d dt of this vut. So now, this is very important for us to pick up. Let us now carry on here. Because both of these are changing, right? When we take the derivative, we're going to use the product rule. But now we're going to see that not only is the magnitude changing, but also the direction is changing. Okay, so let's use the product rule to take the derivative of this. It's going to be dv dt times ut, derivative of that times that, plus that times the derivative of the second thing. dv dt times ut plus v times du dt. Okay? And we can see that this is our v dot, right, which is just our at. I'm just going to put that there. dv dt is v dot equals at. So I'm going to put that there, at. My at is just my change in my speed, the change in velocity, and that is in the tangential direction. But what do we have here? Sorry, we have v times ut dot. This is perhaps something that you've never seen before. It is the change in the direction. That is ut dot. That means the change in the unit vector in the tangential direction. Okay? So without going into the whole derivation, what we need to see is that the acceleration, right, in the normal and tangential components has two components. Okay? First component, second component. The first is just a change in speed. change in speed. Okay, so let me just cross that out. So what does that mean? I'm going at 10 meters per second, then I move to 12 meters per second, right? This is what we are used to, okay? But this is an acceleration component that refers to the change in direction. So guys, acceleration is not only a change in speed, but it's also a change in direction. That's important for us to see, okay? So without going to the full derivation, this just stays like that. It's AT UT. And then this thing here becomes V squared over rho UN. UN, okay? So the change in the tangential direction, the unit vector, when we carry out a full-on derivation of this, we end up with this. We end up with these two components, AT in the tangential direction, and V squared over rho, which is in the normal direction. Okay? Okay, in the next video, I will go through more detail on what this, on how to work with this. But what we need to see is acceleration has two components. It's a change in speed component and it's a change in direction component. Cheers.